In this video, we are looking at velocity time graphs. In particular, we're going to be looking at how to find the distance travelled using a velocity time graph. But first, let's answer some easier questions. Let's see what the question says. Joe's velocity during and immediately after a running race is shown. He crosses the finishing line 16 seconds after starting and takes some time to come to a stop. What is the top speed reached by Joe? Now remember, velocity is simply speed in a particular direction. And we can see from this graph that the highest speed reached is 8 meters per second. So that's our answer to the first question. Next, how long does it take Joe to stop after he crosses the finishing line? Well, we know he crosses the finishing line 16 seconds after starting, so at this moment in time. However, he doesn't come to a stop until he reaches a speed of 0 meters per second. Notice he gets back down to a speed of 0 by 18 seconds after starting. So this is when he crosses the finishing line. This is when he comes to a stop. So that means it takes him 2 seconds to come to a stop after crossing the finishing line. Next, how far does Joe travel in the first 4 seconds? Now, this is the main point of this video. If this was a distance time graph, it would be easy. We would simply read up from 4 seconds and read across to find the distance. However, this is not a distance time graph. What we need to do is, in fact, find the area under the graph. Now, this sounds a little bit weird, but just watch what I do first. Now, I'm only interested in the first 4 seconds, so I'm going to start from this point, from 4 seconds, and draw a straight line upwards like this. Now, the distance travelled is going to be the area of this triangle. It is the area under the graph up to this point here, up to 4 seconds. Now, we know how to find the area of a triangle. It is simply base multiplied by height divided by 2. Now, in this particular case then, we have a base of 4 multiplied by a height of 8. And then we're going to divide that by 2. Base times height divided by 2. And if we work that out, we end up getting an answer of 16. Now, we need the correct units here, 16 what? Well, bear in mind we were trying to work out a distance, how far Joe travels. And what we effectively multiplied together was 4 seconds by 8 meters per second. And when you multiply seconds by meters per second, you end up with meters. So Joe travels 16 meters. Now, some of you might be feeling a bit confused because I talked about this being the area under the graph, and you're used to area being measured in units like centimeters squared or meters squared. But that's because the sides that you'd be measuring would be measured in something like centimeters or meters. In this particular graph, we're not multiplying meters by meters to get meters squared. We are multiplying seconds by meters per second. And when you multiply those units together, you get meters. So there's our answer. Joe travels 16 meters in the first 4 seconds. In question D, we need to work out the total distance of the race. Now remember, he finishes the race after 16 seconds. So what I'm going to do is draw a line up from 16 seconds. Now, to find the race distance, we need to find the area under the graph up to this point. Now, this shape here is not an easy shape to find the area of, but fortunately, we can split it up. Remember, in the previous part of the question, we'd already worked out that the area of this triangle on the left was 16, and that represented a distance travelled of 16 meters. Now we also need to find the area of this shape here, and then we can add that to 16. This second shape is a trapezium. So we can either use the formula for the area of a trapezium, or we can split it up into a rectangle and a triangle. Now I'm going to split this up into a rectangle and a triangle, but if you're comfortable with the formula for the area of a trapezium, then you can just go ahead and use that. So here's my split. I've got a rectangle here where the base is 12, so it goes from 4 to 16, so that's a base of 12 seconds, and a height of 6. That's 6 meters per second. Now, when you multiply 12 by 6, you end up getting 72. So that bit there represents a distance of 72 meters. Let's work out the area of this triangle. This triangle has a base of 12, the same as this, and it's got a height of 2. That's the difference between 8 and 6. So height 2, base 12. The area of a triangle is base times height divided by 2. 12 times 2 divided by 2 is just 12. So that is a distance of 12 meters. Now I'm just going to get rid of some of the markings on here so it's all clear. The total distance that Joe travelled to the end of the race, so up to this time, up to 16 seconds, is 16 meters plus 72 meters plus 12 meters. If we add those up, we get a total of 100 meters. So this was a 100-meter race. Finally, we have to work out how far past the finish line Joe travels. So obviously, when he crosses the finishing line, he's still running quite fast. He's not going to stop dead at the finishing line. He's going to carry on, slowing down until he comes to a stop. And the question is, how far does he continue to run? Well, that is the distance that he runs between 16 and 18 seconds after starting. That's when he comes to a stop, remember? And that distance is simply the area of this triangle down here. So that triangle has a height of 6. It has a base of 2. And remember, the area of a triangle is base times height divided by 2. So that's 2 times 6 divided by 2, which is just 6. So he only travels 6 meters past the finish line.